Serena.
Hi.
Hi. So are you, you're in my class or are you one of the tutors? I'm still learning everybody.
I'm in your class.
Oh, okay, sounds good. So this is just kind of like an open hour. So it's just for students to like ask any questions or anything like that. So how's everything going so far?
Everything's going pretty good.
Awesome. Do you have any questions at all about the material that we have covered so far this week?
No, everything seems to be going good. I think I got it.
Okay, sounds good. So this is kind of like an office hour just to make sure everybody's doing okay. So you're welcome to hang out and see what other questions students have. Let's see, remind me, have you been in one of my other Zoom sessions, the one that I had on Monday?
Yes.
Okay, cool. Sounds good. So I'll be doing another one with a different group today at 2, and then we'll be posting that link so you can kind of watch it and see, you know, some more of the examples and stuff that I go over with that group. So
cool.
Hi, Miranda.
Thank you.
Hi.
You're welcome. Miranda, what's your last name?
Diaz? Isn't it on right now?
There you go. Yeah. And
okay.
you also look familiar, right? Weren't you with me on Monday?
Yeah.
Okay, awesome. So is everything going well for you so far?
Yeah, so far it's been pretty good.
Good. Awesome. Yeah. Any questions?
No, not right now, actually.
Okay.
Yeah.
Sounds good. I mean, since I'm not meeting with you guys today, I can go over some of the questions that I'll be going over with my next group if you want to kind of just see what I have planned for them. Like I was telling Serena, I'll meet with my group from 2 to 3 today, and then that video will be posting. But I already have questions if you want to review some of the recent stuff.
No, I think I got it.
Okay.
Yeah.
Awesome. You're good with like the frequency tables and bar graphs. Okay, I have a question for you.
Yeah.
Who can tell me the difference between a bar graph and a histogram? That's a really good question.
A histogram is like for it's like numerical, and a bar graph is like for like categorical. Exactly.
Perfect. And also visually, there's another difference. So when you visually look at it, you can tell which one's for which without looking at it too closely.
One has like a space, another one doesn't.
Yeah, that's what it says.
Which one has the spaces? Remember?
Yeah.
Who knows which one has the spaces?
I think the
bar graphs.
Yeah, and the histogram doesn't have one.
Yeah, way to go. Bar graphs, perfect. So the histograms, your bars are always touching. They're for numerical. So if I just show you, where did you guys go now? I don't see you. Oh, I know why. I have to press share screen. Share screen. But if I show you, can you see my screen or no? Not yet.
Not yet.
Uh-oh. I'm saying, this is good. Good practice for me because it's not working. Let's try again. Exit. Share. Can you see it now?
Yeah.
Perfect. Let's see. So here, oh gosh, we have to wait. It made it typed too slow. I need to adjust that. Let's actually, I'll do this. So here's like our bar graph that shows like, I don't know, I just found a random one online, like people who like comedy versus action, romance, drama, or sci-fi for their favorite kind of movies. So you can see that like, you know, like we were talking about with the bar graphs, it has the spaces. But then what I wanted to point out, if this can move fast enough, for our histograms. Oh, another thing that I wanted to make sure I mentioned, because I noticed in a couple of the videos, sometimes they go back and forth between these terms. So if you see them, you know what it's referring to. So if you ever see them mention quantitative, quantitative means numerical. And then the other term is qualitative. Sometimes you might see the term qualitative, and that's your categorical. So how I remember the difference between the two is quantitative is the one with the N in it, like numbers. And qualitative is an L for like labels, like our categories. So when we're testing you, we'll probably always use like numerical versus categorical, but when you're watching other videos and stuff, if you see quantitative come up, again, that's referring to your numerical data values. And qualitative is like your labels. So sometimes that can be a little confusing because there's different ways. So the histograms, like this one here, we see how like our bars are all right next to each other. And the reason why it's for numerical data is if you notice like what looks like our x-axis along the bottom, our horizontal axis, right? It shows a range of numbers. Mm-hmm. So because of that range of numbers, that's why our bars will always be touching. Mm-hmm. So just something to kind of keep in mind. And if you want, you can answer these questions. I'll make them go fast. So like based off of this chart, can you figure out what's the observational unit?
Black cherry trees.
Exactly. Did I make my chart big enough? I can always make it bigger too for my next class. And then it says how many black cherry trees were sampled. Can we determine that? Might take us a little bit.
Were sampled? Is that what it was?
Yeah, like how many cherry trees were measured, like for their heights?
6.
So if you look here, I don't know if I can use like an arrow, but if you look at the first rectangle, right, from 60 to 65, how many trees were 60 to 65 feet tall?
5.
How many?
Oh, wait, 3.
3, exactly, because we see it's right between the 2 and 4. So there's 3 for the first. We call it a class, right, that group. So for the first class, it's 3. The next class we also sampled 3, it looks like. Then 70 to 75, there were 8, right? 75 to 80 were 10. 80 to 85 looks like 5. And then 85 to 90 was 2. So what does that add up to? 3 plus 3 is 6, plus 8 is 14, plus 10, 24, plus 5, 29, plus 2, 31.
Yes, okay, I get it.
It looks like there were 31 cherry trees sampled. And then it says, what class had the highest frequency?
75 to 80.
Exactly. So that we had the most that were between 75 and 80 feet tall. It said how many trees had a height that was greater than, no, I can't see that.
75 feet.
75?
Yeah.
So how many would that be?
Let's see.
Is the last one 85 to 90? Is that 2 or 1?
It looks like it's 2.
Okay.
So they're like 17?
Yeah, that's what I got too. Awesome. So you just added up the frequency for each of those classes. How many trees were less than 70 feet tall?
6.
Yep. And were any trees 92 feet tall?
No, right?
Exactly, right? We don't see anything that goes beyond it, so we can assume the answer is no. So again, that's just a little bit on the histograms. I'll stop sharing and look and kind of go through and see if there's anything else. What about your stem and leaves? Are we good with stem and leaves?
Yeah.
Okay. Sounds good. I have this one. Oh, wait, I have to press share. So for this one, what would our stems be?
The numbers except the last one?
So this, yeah, exactly. It's the numbers except for the last one. So since most of these are 2-digit numbers, what would be, in order, what would be my first stem, my second stem, and like how many stems would I have? So let's start with this. What would be my first stem? What's my smallest number in this list?
3.
Exactly. So this is one that's tricky because all the other ones it shows are 2-digit numbers, right? Mm-hmm. So if I was to write 3 as a 2-digit number, technically, since notice again, since they're two digits, that means we have a 10 spot and a 1 spot, right? So the 3 is obviously in the 1 spot. So that means what invisible number does it technically have in the 10 spot?
0.
Exactly, a 0. So that would mean our first stem would be a 0. And then our next stem would be a 1, 2, 3. What's our highest stem going to be?
59.
Yeah.
Yeah, our highest number is 59, so the 5 will be our highest stem, right? So when we set it up by hand, this is what our stems will look like, right? All of our 10s digits. So then our leaves will go over here.
Yeah.
So for example, the smallest number is 3. So I would just write a 3 like that. And that indicates the number that's 3.
Mm-hmm.
Right? And so then looking at all the ones with the 1, we have a 12, 11, 2, and 2 16s, right? Got everything that has a 1 in the 10 spot?
Yeah.
12, 11, 16, 16. So that means, do you know what that would, those leaves would all look like?
Yeah, like a 1, and then the line, and like a 2.
So it'll go 1, and then 2, and then the 6. Since there's 2 16s, what do we do about the 2 16s?
Just add a 6.
Yeah, we'll put we'll put 2 6s. So like, this shows that we've got 11, 12, 16, and 16. While we're at it, let's just go ahead and finish the problem. I think this is one of the trickier things, aside from like the histograms versus bar graphs. So I'll give you guys a minute to go ahead and finish it, and then we'll compare our stem and leaf. I'll do it with you. Let me know when you guys are done. We can compare our answers.
Yeah, I finished.
Yeah, I'm done too.
Okay, should we all hold them up at the same time? Okay, 1, 2.
I don't know if you can see mine.
Mine's a little small.
These are small.
Mine's like right. I don't know if you can see it.
Yeah,
Like,
mine's right there.
Okay, cool. So
mine's there.
the interesting thing is, since there wasn't anything with the 40, we all knew to put the 4 and then leave the space there. And when the numbers repeat, we do our, like the zeros, we can see there's 2 30s and so forth. So good.
Yeah.
Awesome. And then obviously if I gave you this, you could easily turn it back into that list of data values. Perfect. Sounds good. Okay, I'll stop sharing. So of all of the different like visual representations you guys learned about in today's module, which one would probably be the least preferred one to use?
Let's see.
It's the one that is most often used to misrepresent data. I don't know if you read, have you guys, I know you've got all your different videos and all of that to go through, but you also have like the textbook to read through. Have you read the textbook?
I skimmed through it actually.
Okay. Yeah, it's pretty quick and easy. But it gives like a little blurb on one of the visuals and which one is the least preferred one to use. But if you haven't read it, you still have time, but what might be your guess?
I say bar charts because like I feel like people would also use it for like numerical like other things. So like you can get like yeah.
So I think what's nice about the bar graphs is again we know it's for the categorical data and it's kind of easy to see which one's more or less. So actually the one that the book talks about, so definitely make sure you go back and read it, is our pie charts. Because the pie charts, sometimes it's a little harder to compare one group than another. And so I'll show you this slide. And then also sometimes when you're like watching the news, they'll create like these 3D, sometimes it's a pie chart, sometimes it's kind of like similar to a pie chart. But they purposely do it to kind of confuse the viewer because we as a typical viewer is going to have a harder time kind of comparing volumes. So typically with the pie charts, they're fine, but they're not the best when it comes to comparing your data, right? When we have like those vertical rectangles, we can more easily see how they compare. But then you definitely want to avoid ones that look like sort of 3D figure because you can misconstrue the data with your volume and so forth. So the worst one to use is the pie charts. Doesn't mean you can't use it, but sometimes they're used to confuse the viewer. So just something to keep in mind.
Yeah.
So any questions? You don't have to hang out with me the whole hour. I can always find more things to talk about for math. Or if there's any problems at all that you wanted to go over or anything, that's what I'm here for. And then I have another like official office hour tonight at 8:30 to 9:15. So as you're getting more work done or looking ahead, you can log on and feel free to ask me any other questions.
Okay. I think for now I'm good.
Okay.
So, yeah.
Sounds good. Well, I won't hold you captive, but if you do have any questions, you know where to find me. I'll be here till 2.
All right. Thank you.
You're welcome.
Bye.
All right. I think I'm good too.
Okay. Sounds good.
All right.